Hello, my name is Daniel, and today we will be going through the AMC 10 from the year 2001. So let's get right into it. The first problem, it's the median of the list n plus 3, n plus 4, n plus 5, n plus 6, n plus 8, n plus 10, n plus 12, n plus 15. So the median is 10. So how many numbers are there? First 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So the median of 9 numbers would be the fifth number, so it will be n plus 6. N plus 6 equals 10, so n equals 4. So from there, n is 4, so if we add them together, it's n plus, so the mean is over 9, and it's 9n plus 3, 4, it's 7, it's 12, it's 18, 26, 36, 48, 63. 63 equals n plus 7, n plus 7, and since n is 4 plus 7 equals 11. So the mean is 11, so the answer is E. Problem 2, the number x is 2 more than the product of its reciprocal and its additive inverse. So x is 2 plus the product of its reciprocal minus x times its additive, its reciprocal is 1 over x times its additive inverse, which is minus x. So this is 2 minus 1, so it's 2. No, it's 2. 2 minus 1 is 1, obviously. So it is in 0 to 2, so it's C. Problem number 3, the sum of two numbers is S. Suppose 3 is added to each number and then each of the resulting number is doubled. What is the sum of the final two numbers? So 3 is added to each number, so in total it's plus 6, so it's S plus 6 now, and then each of the resulting numbers is doubled, so it's 2 times, so it's 2S plus 1, no, so it's 2S plus 12, so it's E. And problem number 4 was the maximum number for the possible points of an intersection of a circle and a triangle. So the maximum of a circle and a triangle is obviously 1, 2, 3, 4, 5, 6 points. So it's E. Problem number 5. How many of the 12 pentagonals pictured below have at least one line of reflectional symmetry? This one has a line here. This one does not. This one does not. This one also does not. This one has one here. This one has one here. This one has rotational symmetry but not reflectional symmetry. So this is also wrong. This has one here. This has one here. This does not. This does not, and this has one here. So there is this one, this one, this one, this one, this one, and this one. So there's 6 in total. So that's D. Problem number 6, Pn and Sn denote the product and the sum respectively of the digits of the integer n. So P23 equals 6, S23 equals 5. So if n is a 2-digit number, then let's say that n is 10a plus b, then n is Pn plus Sn. So 10a plus b equals ab plus a plus b. So b would go, and dividing by a, 10 equals b plus 1. So b is 9. B is the units digit, so b is 9, so it's E. Problem 7. When the decimal point of a certain positive decimal number is moved 4 places to the right, the new number is 4 times the reciprocal of the original number. So it's moving 4 places to the right, so it's 10,000x equals 4 times the reciprocal of the original number. So x squared equals 0.0004. So x equals root 0.0004, which is 0.02. So it's C. Problem number 8. Wanda, Darren, Beatrice, and Chi are tutors in the school math lab. Their schedule is as follows. Darren works every third school day. Wanda works every fourth school day. Beatrice works every sixth school day. And Chi works every seventh school day. So it's 3, 4, 6, and 7. Today they are all working. And how many school days from today will they next be together tutoring in the lab? So it's 3, 4, 6, 7, and we're trying to solve the LCM of this. LCM. This is 6 times Yeah, this is basically 12 times 7, since it's 3, 4, and 7. So it's, what is it? 484. It's B. Problem number 9. The state income tax where Kristen lives is levied at the rate of P% at the first 28,000 of annual income plus P plus 2% of any amount above 280,000, above 28,000. The state income tax she paid amounted to P plus 0.25% of her annual income. So it being that it's more than P%, that means she will earn more than $28,000. So it's 280P plus if there's X dollars more, X dollars more, then we will have P plus 2 times X over 100. This equals P plus 0.25 times 28,000 plus X over 100. So 28,000 P plus 2 X equals. So let's make this, let's expand this. Px plus 2x. This is px plus 0.25x plus, so it's px plus 0.25x plus 28,000 p plus 7,000. So we can erase these two and these two. So what will be left is 2x. 2x is 1/4 x, because 1/4 is 0.25 plus 7,000. So 7 over 4x equals 7,000. X equals 4,000. So her annual income is $4,000 more than 28,000. So 4,000 plus 28,000 equals 32,000. So it's B. Problem number 10. If x, y, and z are positive with xy equals 24, xz is 48, and yz is 72, then x plus y plus z is... So if we multiply all these, then x squared, y squared, z squared equals 24 times 48 times 7. No, we don't need this. Yeah, so from these three, we can just think about what x could be. So 72, this is likely to be like 6 times 12, right? And then 48 will be 6 times 4. No, it will be 6 times 8. But then 8 times 12 won't be 24, so that's not right. So 4 times 12, then yes, and then this will be 6 times 4. And then so x would be 4, y would be 6, z would be 12, x plus y plus z equals 22. So it's D. 11. Consider the dark square in an array of unit squares. So the first ring contains 8 unit squares. So the first ring is these two. So this much is the first ring, but we can we can split the split the ring into 4 parts. These, this. So it becomes like 4 times 2, and then and then the next ring would be these. No, it will be these, and these. So it's 4 times 4, and then the next ring would be these 6, these 6, these 6, and these 6. So it will be 4 times 6, and so this would be 8 times 1, 8 times 2, 8 times 3. So this is the first ring, second ring, third ring. So all the way to the 100th ring would be 8 times 100. So this is 800. So the answer is 800, which is C. Problem number 12. Suppose that n is the product of three consecutive integers and that n is divisible by 7. Which of the following is not necessarily a divisor of n? So if it's the product of three consecutive integers, so it's three integers, so it has to be a divisor of 3, and it's more than 2, right? So there has to be 1 even and 2 odd, or 2 even and 1 odd. So it has to be a divisor of 2. So and it's divisible by 7, so it's divisor of 7. So 6 is made by 3 and 2, 14 is made by 2 and 7, 21 is made by 3 and 7, 42 is made by all of these, but 28 is but 28 is made of 7 times 4, and it doesn't have the second 2 to make the 28, so it's D. Problem number 13. Telephone number has the form ABC minus DEF minus GHIJ, where each letter represents a different the digits in each part of the numbers are in decreasing order. And D, E, F are consecutive even digits, G, H, I, and J are consecutive odd digits, and A plus B plus C equals 9. So for D, E, F to be consecutive even digits, then this must be like 8, 6, 4. And then G, H, I, J, they are consecutive odd digits, so they must be like 9, 7, 5, 3. So the only ones left are 1. It's 1, 2, and 1, 2, and 0. Yeah, but that doesn't make sense. So they have to be consecutive even digits. So we have to fix something. Then we can make 8, 1, 0 left over, and so DEF would be 6, 4, 2. Yes, and so A plus B plus C is 9. A is the biggest out of these 3, so A is 8. So it's 8. So it's E. Problem number 14. Charity sells 140 benefit tickets for a total of 2001. Some tickets sell for a full price, a whole dollar amount, and the rest sells for half price. How much money is raised by the full price tickets? So it's 140 and equals 2001. No, so there's 140 benefit tickets. So there's full price. So there's N that sold for full price. And 140 minus N that sold for half price. So 2001 equals, if the full price is X, then half price would be X over 2. So it's NX plus 140 minus N multiplied by X divided by 2. So this would be 4002 equals equals NX. So it's NX plus 140X. And so this would be X times N plus 140. Which means that, and so X would have to be a divisor of 4002. So 4002, if we dissect 4002, this is, first of all, it's 6, and then it becomes 667. 6 becomes 2 and 3, and 667 is divided into 23 and 29. So 2, 3, 23, and 29. Keeping that in mind, 2, 3, 23, 29. And so what we're looking for is xn, right? So xn is 4002 minus 140 x. No, yeah, so it's 140 times xn is 4002 minus 100 minus 140x. So it's, what is it? Yeah, so it's 140 times 20. And so here n would be 23, and so x would be 34. And so how much money is raised by the full price tickets? And x, this is 23 times 34, which is 3, no, which is 782. So it's A. Problem 15. A street has parallel curbs 40 feet apart. A crosswalk bounded by two parallel stripes crosses the street at an angle. The length of the curb between the stripes is 15 feet and each strip is 50 feet long. Find the distance in feet between the strips. So to illustrate this, there are parallel curves 40 feet long, 40 feet apart, and then crosswalk bounded by two parallel stripes crosses the street at an angle. So it's like this. Crossing the street at an angle. The length of the curb between the stripes is 15 feet, so it's saying that this much is 15 feet. And the curves are 40 feet apart, so this much is 40 feet. And then each stripe is 50 feet long, so this much, it's 50 feet. Oh, yes. So they're trying to say that this is 40 feet, right? This much down here, this is 40 feet. And so this must be 30 feet. Find the distance in feet between the strips. Oh, yeah, so I was wrong. This isn't 15 feet. Actually, this part is 50 feet. This is 15 feet. And so what we want to do is find this distance. Yeah, what distance could this be? So this triangle and this triangle, they are similar, right? So this 15 and something is equal to the ratio of, this is 50, 40, 30, right? So it's 5 to 4 to 3. So if you multiply by 3, 15, 12, and 9, so this has to be same as this. So the mystery distance is 12 feet. So it's 12, it's C. Problem number 16. The mean of three numbers is 10 more than the least of the numbers, and 15 less than the greatest. The median of the three numbers is 5. What is their sum? So the mean is 10 more than the least of the numbers. So if there is A, B, and C, the mean of three numbers, so A plus B plus C over 3 equals 10 plus A equals C minus 15. If A, B, C. The median of the three numbers is 5, so B is 5. B is 5. So this becomes something with A and C. Since B is 5 now. And then so with this one, A plus C plus 5 equals A equals 3A plus 30. 2A minus C equals minus 25. And then for these one, A plus 5 plus C equals 3C minus 45 minus 45. So 2C minus A equals 50. So if you add up these two, then it becomes that A plus C equals 25. So what is their sum? So A plus B plus C equals A plus 5 plus C. equals 5 plus a plus c equals 5 plus 25, which is 30. So it's 30, it's D. And problem 17, which of the components listed below could be formed from a 252-degree sector of a circle of radius 10 by aligning the two straight sides. So you would put these two sides together into a cone shape like this, and then this would have a length of 10, and then since 252 is 252 over 360 equals divide by 2 divide by 22, then it's 126 and 180, which becomes 621 and 30, which is 6 over 7, no, which is 7 over 10. So it's 7 over 10. So the circle of radius 10. So the total circumference of the circle equals 20 pi, right? But then the length of this arc equals 20 pi times this much, so it's 7 over 10 equals 14 pi. So circumference of this circle right here, this would also be the same as the arc of so the circumference of the base, which is right here, this should be the same thing as this, so it's 14 pi, and so radius is 7, and so the slant height is 10, and the radius is 7, so a cone with slant height of 10 and radius 7, it is C. Problem 18, the percent of the plane that is enclosed by the pentagons. So these are basically this shape that's patterned, and it's just this being repeated all over again. So if you see here, this much is what it's talking about, since it's talking about the pentagons, and the pentagons are taking up 5 over 9 of the entire space. So now what we have to do is put this into a percentage. So it's 5 over 9 times 100 equals 500 divided by 9. So it is 5, 45, 56, 55, 45, 50, so it's 55.55555. So it's closest to 56, so the answer is 56. Let's move on to problem 19. Pat wants to buy 4 donuts from an ample supply of 3 types of donuts, glazed, chocolate, and powdered. So there are 3 types of donuts, but he wants to buy 4 donuts. So for this one, we'll use the stars and bars method. We have to buy 4 donuts, so it's stars, 4 stars. But then the bars, there are 3 types of, so there are 2 bars. So there are 5 slots for the bars, so 5 choose 2, and then we have to add 5 more. Why? Because there could be these 2 bars both in here, or here, or here, or here, or here. So there are 5 more possibilities that aren't considered in 5 choose 2. So this is 10 plus 5, so it's 15. So the answer is 15, D. Problem number 20. A regular octagon is formed by cutting an isosceles right triangle from each of the corners of a square with size of length 2000. So let's make a square with like this, and then cutting the isosceles right triangles. So like this, no, way too big, like this, and this. No, like this. Okay, so what we need to, so this, all these lengths are the same since it is a regular octagon. So if this length is A, then this would also be A. So since this is an isosceles right triangle, this length is A over root 2, and it's same for here, A over root 2, and so A plus A, so it's A plus root 2, A, this is 1 plus root 2, A, and so this is 2, and so this is 2000, because it said that the square is length 2000. So A, this is 2000 over 1 plus 2, 1 plus root 2, and so this is 2000 times root 2 minus 1, so this is 2000 root 2 minus 1, so it's B. Problem 21, a right circular cylinder with its diameter equal to its height is inscribed in right circular cone. The cone has diameter 10 and altitude 12. The axis of the cylinder and the cone coincide. Find the radius of the cylinder. Okay, so what we have to do is first we have to draw the axis, and then we'll draw the cone. And let's move this slightly like this, and then we can have the circular cylinder like this cylinder, and then same thing, bottom here, about this wide and flat. So it's here. And then we can make the cylinder like this and like this. So if we kind of press this down from this from the front, then we'll get like a cross section. So the cross section would be like there's a triangle, and there's a rectangle. And there's the axes, which are the same, and so it doesn't really look like isosceles, but so let's try red isosceles triangle like this. Yes, that's better now. So we'll be doing like this. Yeah. So here, if this length is A, then this must be 5 minus A, because the diameter is 10. So this whole thing is 10, and so the radius is 5. So if this is A, then this is 5 minus A, and since the altitude is 12 and this much is 5, then and this is a right triangle, then the slant height has to be 13 because of Pythagoras, and so also the slant height is 13 for here, and since this triangle is similar to this triangle, we can say that the ratios are the same. So this length would be 13 over 5a, and this would be 12 over 5a. But then we said that the diameter is equal to its height. So actually, this should not be a rectangle; it should be a square. So we can't like actually make it into a square. But then this length should be the same as this length, right? So 12 over. This was way too far out. This much is 13, and then this is the same as this, right? So 12 over 5a equals 2 over 5 minus a. This is 10 minus 2a, so 22 over 5a equals 10. A is 50 over 22. So find the radius of the cylinder. Radius is 5 minus a. This is 5 minus, if you divide this 11 and 25, it's 5 minus 25 over 11. This is 55 minus 25 over 11. This is 30 over 11. So the radius of the cylinder is 30 over 11, and the answer is B. Problem number 22. In the magic square shown, the sums of the numbers in each row, column, and diagonal are the same. So we can say that these two and these two are the same because these two plus v equals these two plus v. Oh, yeah, let's just write it. 18 plus 25 is 43 plus v. This is 24 plus w plus v. If we take out the v from both sides, then it's 43 equals 24 plus w. So w equals 43 minus 24, so it's 19. So w is 19. And then what we have is, it's also the same as v plus x plus 21. So this is also the same as v plus x plus 21. So if we take out the v, this is x plus 21, right? So 43 it equals to x plus 21. X equals 43 minus 21 equals 22. So this is 22. But then this should also be the same, right? So v plus 18 plus 25 equals 25 plus 22 plus 19. So if we take out the 25 and take out the 18 and leave a 1, v equals 23. V is 23, and then we have to find y plus z. And so, since v is 23, the total is always, the total is always 23 plus 18 plus 25, which is 66. And so y equals 66 minus 19 minus 21, so it's 26. And z is it's 66 minus 25 minus 21, which is the same thing as 20. So y plus z, this is 26 plus 20, this is 46, so 22 is D. Number 23, a box contains exactly 5 chips. 3 red and 2 white chips are randomly removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. What is the probability that the last chip drawn is white? So, there's a box. There's a box with 5 chips. There's 3 red chips and 2 white chips. There's 3 red chips and 2 white chips. Chips are randomly removed until all the red chips are drawn or all the white chips are drawn. Okay, so that the last chip drawn is white. So last chip is white. It means that it finished because all the white chips were drawn. So it has to end in white. Okay, so for something to end in white, then let's so for something to end in white, then it can't have all 3 reds, and it must have at least 1 white before the last white. So it has to be either white, red, red, and then change the order of these: red, white, red, 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 white, and then the end would always be white. And then if there were if there were only 1 red before the white, then it could be white, red, and then white, or red, white, and then white. And then the last way would be that it's just first time white and the second time white. So we can get rid of this. And what's the probability that the last chip drawn is white? So for these ones, we can say that this is 2 over 5. So first we'll draw the white chips, right? 2 over 5 times the red chips, and the 3 over 4 and the red chips, and then times the 2 over 4, no, 2 over 3. And so this would be 1 over 5, right? But then it would have to be multiplied by 3, since there are 3 times, and it would have to be multiplied by 1/2, since we have to choose which one of the whites is coming first. So it's times 1/2, so this becomes 3 over 10. And the second one it's these two. These are 2 over 5 times the red, 3 over 4. So and then here are 2, right? So it's 2, and then times 1 over 2, no, times 1 over 3. So this becomes, these cancel and these cancel, so it's 1 over 5, 1 over 5. And then this white one, this is just 2 over 5 times 1 over 4, so it's just 1 over 10. So 3 over 10, 5 over 1, 10 over 1. If we add these up together, then what do we get? 4 over 10, so it's 2 over 5 plus 1 over 5. This is in total 3 over 5, so it's D. Problem 24. In trapezoid A, B, C, D, AB and CD are perpendicular to AD with AB plus CD equals BC. AB is less than CD and AD equals 7. Okay, so let's have the trapezoid. It could be like this, maybe. And then it would be A, B, and CD are perpendicular to AD. Oh, so they would have to be at a right angle, like this. And then with AB plus CD equals BC, so if this is A and this is B, this is A plus B, and then if you draw a line here, then this is A minus B, this whole thing is B, and AB is less than CD, and AD equals 7, so A plus B squared equals 7 squared plus A minus B squared, so 2AB equals 49 plus 49 minus 2AB, 4AB equals 49, AB equals 49 over 4, so AB times CD, this is A, what they want is A times B, and that's exactly what we've got. So we have to put this into a decimal form, right? So this is 49 times 25 over 100, so 49 times 25, 45 to 45, 18, 4 times 2 is 8, so it's 9, 1, 2, 2, 5, 12.25, so it's B. Last problem, problem 25. How many positive integers not exceeding 2001 are multiples of 3 or 4 but not 5? Okay, so to make this problem easier, we can make like a Venn diagram, kind of like this. And so positive integers not exceeding 2001 are multiples of 3 or 4 but not 5. So this could be of 3, a 4, and a 5. So let's label the areas A, B, C, D, E, F, G, right? And then what we want is multiples of 3 or 4 but not 5, so we want this much. So what we want is A plus B plus E. And now how do we get this? So this is so this can be gotten by A plus B plus C plus D. This is 3, and then minus this much, which is C plus D, so we'll have this much left, right? Plus, yes, plus B, C, E, F. This is this much, and then minus this much, so it's C and F. So this would this would result in A, B, E, A plus B plus B plus E. And so now we have to get rid of one of the B's. And so to do that, we can do plus B plus C, this much, and then take out this much, minus C. So if we put it all into the words of multiples, A plus B plus C plus D, this is the multiple of 3, minus C plus D is 3 and 5, so it's 15. And then plus B, C, E, F, this is multiples of 4, plus 4, and then C plus F, this is 4 and 5, so it's 20, minus 20, and then plus B plus C is this much, so it's 3 and 4, so it's 12, minus C, this is 3, 4, and 5, so it's 60, minus 60. No, actually we have to take out one B, right? Yeah. Sorry, yeah, this has to be minus B plus C and then plus C, because we have to take out one B from this one. So this would be a minus 12 and a plus 60. Okay, so let's erase this, and then let's put this up here. And so, yeah, and we don't need this too. Multiples of 3, 4, 4, but not 5. So they can't exceed 2001, right? So multiples of 3, 2001 divided by 3 are 667. So this much is 667, and then minus 15. Yeah, we have to do 15 divided 2001 divided by 15, which is 1, 15, 53, 45, 51, 3, so it's 133 plus 4, so we have to divide 2001 by 4, so it's 5, and then it's 20, and 0, 1, so it's 500, so it's 500, and then we have the 20s, 2001 divided by 20, this is basically 100, so this is 100, and then minus 12, 2001 divided by 12, this is 1, 12, it's 80, and then we'll have 6, so 60, 72, 81, 6, and then so it's 166, and the last 60, it will be 2001 divided by 60, which is 3 here, 180, 201, 3, 180, so it's 33. So the actual arithmetic would be 667 minus 133 plus 500 minus 100 minus 166 plus 33. This much is 400. This much is minus 133. So this much is 267. This much is 534. This much is 700. No, this much is 801. So the total value is 801. So it's B. This was problem 25 of the 2001 AMC 10, and thank you for watching.